All right, we've got an interesting interview with Ruth Ann Foster, who's with the Weston Price Foundation and wrote an intriguing article about oxalates for the spring edition of the Wise Traditions Journal for the Weston Price Foundation. And we're excited to have her on to discuss some of her findings and that align with my beliefs about the microbiome, which is that the microbiome is the single most important part of your health. And unless you understand why almost everyone watching this has a seriously impaired microbiome, not necessarily due to any conscious choices on your part, but due to decisions that were made by people that have long since passed away from this planet, yet their marks have been left, and you are left with the consequences of that, which is essentially literally destroying large portions of your ability to generate cellular energy through your mitochondria. And when you do that, when you don't have that energy, your body doesn't work the way it was designed, and you gradually start to die prematurely. And one of the ways that occurs is through your gut microbiome. And we're going to touch on how to reverse that today. And it's a sort of a precursor for my new book, Cellular Health, which is coming out shortly. All right, so enjoy the interview.
I found that, there are a lot of ancestral tribes and communities that ate a lot of oxalates, and a lot of people that are still eating them today. So then I started looking more into kidney stone disease and realized, yes, while it's been around since antiquity, that it really has taken off exponentially since the Industrial Revolution, since we started eating processed foods. Highly processed food is really what is destroying the gut. And then that lays everything open for oxalate. And then you want to correct. And so you start eating healthy, and then you get even sicker. And then instead of blaming the bad food, you blame the healthy food. And what is causing kind of the damage is a disrupted gut. Mm-hmm. It's not dietary. Unless we are really looking at the bacteria that we have on board or not, then we're totally missing the point. That's one of my biggest take-home messages is the gut and everything that we're doing. We're not just feeding ourselves, we're feeding them too.
Welcome, everyone. Dr. Mercola helping you take control of your health. And today we are joined by Ruth Ann Foster, who has written a really wonderful article for Sally Price Wise Traditions Spring 2024 Journal on oxalates, a topic that is quite near and dear to our heart because it is quite a problem for many people. And we've had Sally Norton, another Sally, on a few times, and she's written a book on that, and she personally struggles with herself quite severely from oxalates because it can be devastating if you don't know how to get out of this. And Ruth has a deep appreciation of the connection of the microbiome because it really is a central part of the equation, and really the focus of my new book, Cellular Health, which really helps people understand how to recover the microbiome because it's not an easy process. It's not intuitive at all. But it's essential. And when you do, you get those microbes back that digest the oxalates. So Ruth is going to tell us about that, and because she's uncovered a few other microbes other than Oxalobacter that digest oxalates. So welcome and thank you for joining us.
Thank you, Dr. Mercola. It's really a pleasure to talk with you.
Okay, so well, congratulations on writing such a good review of that, such an important topic. So maybe you can share with us what motivated you to write that and, start helping us understand your perspective of the oxalates.
Okay, well, I really got started on oxalates when I was doing my dissertation on magnesium in drinking water. Mm-hmm. And because magnesium is, vital inside the cell, it's an antagonist with calcium, which is mainly outside of the cell. And, the majority of kidney stones are calcium oxalate, and that has coincided with a deficiency in magnesium. So, I was well aware of problems with oxalates. And then I did read Sally's book, and I thought, she's done a fantastic job of really, sounding the alarm of how important it is to watch out for these things, because they can be very damaging, to many, many different systems. So anyway, I ended up with a lot of questions, and I thought, okay, yeah. I know plants.
These questions were after you read her book?
Yeah. Mm-hmm.
Okay.
So I read her book, and then I thought, why are oxalates such a problem? Like, how did they become such a problem? Why are they such a problem? So I started really unraveling and going back and thinking, well, what I had a problem with gut issues after, I think, mercury toxicity poisoning. And so my gut was inflamed, and I went basically mostly carnivore. That was basically all that I could eat, just to balance myself out without having, a million different reactions. And then I thought, what, hey, and my kind of assumption was, well, the Eskimos don't eat 5 servings a day of fruits and vegetables. So maybe there's some truth to this, that maybe plants are a problem. So I started looking into it more closely. And one of the first things, being a Weston A. Price member, as I pointed out in my article, I started thinking, what in the world did our ancestors eat? And did anybody eat oxalates? So I Google searched, and I found that, there are a lot of ancestral tribes and communities that ate a lot of oxalates, and a lot of people that are still eating them today. So then I started looking more into kidney stone disease and realized, yes, while it's been around since antiquity, that it really has taken off exponentially since the Industrial Revolution, since we started eating processed foods and, processing our water too, taking the magnesium out of the drinking water. And so with that, one of the first groups of people that I looked at when I just Googled ancestors and high oxalate diet were the people in the lower Pecos region of, I think it's Western Texas, and they ate a lot of oxalates, but they were able to clear them. And then looking around at that, looking at animals in the kind of desert area, there's a wood rat, a white-throated wood rat, that also consumes, most of its diet in oxalate, cactus and things like that, but it also excretes them. So scientists are now using the wood rat to study our microbiome, and they've taken transplanted some of the fecal material from the wood rat into lab rats, and they've been able to maintain oxalate clearing tolerance for like 9 months later. So there's something going on in the gut microbiome. So I also looked at the Inuits, because again, like I thought, well, they don't eat, fruits and vegetables. And so maybe they're fine. They have on their traditional diet, have very low rates of any kind of kidney stone disease, and they're very healthy. It's only when they switch over that everything just starts, to go haywire. But it turns out there was a wonderful book that I happened to find written in 1991 on indigenous foods. And yes, the Inuits eat a lot of high oxalate foods, and they eat them all year long. They don't just eat them when, their short little growing season. They ferment them, they dry them, and so on. So I was like, wow, okay, that's interesting. I just learned something. Plus, the other thing that they would do is they eat the rumen of some of the reindeer that they find, which is, again, it's going to have some bacteria in it. And that helps them to be able to process through these things. So then looking at Africa, same kind of thing, a lot of high oxalate foods. And in each one of these situations, all of these people have been able to clear the oxalates. So then it really has the industrial food, and also big problem are antibiotics. And we have just we've gone crazy. We were called the era before the probiotic era, and now we're in the antibiotic era, and we're coming out of the antibiotic era back into the probiotic era. So what more, I'll get back to my magnesium story, is when after I finished, I defended my dissertation the day before lockdown. And then I just have been doing research
And
on
you got the equivalent of a PhD, right? A Doctor of Science?
a doctor of science is a PhD, but
Yeah.
through Hawthorne University. And I kind of waited until Hawthorne thankfully had gotten accreditation because it's, it wasn't dietetics. I also, during my doctorate, just a side note here, I did reactivate my RN, which I had, let lapse from a long time ago, just so that I could, in the state of North Carolina, do anything with nutrition, because the dietetics board was, they were moving at that time. So I did reactivate my RN. And so back to my magnesium story, when I started looking into magnesium, that every single living cell requires magnesium inside. And it can't function without. And in fact, then I got into looking at, because I did a lot of raw milk legislative work in North Carolina. I found an article on that terrible pathogen, E. coli 0157H7. And that I read an article on how that E. coli senses for magnesium level in the gut before it lays down a biofilm. And I thought, oh my goodness, wow. Okay. So then that opened a whole kind of research door on a term called nutritional immunity. And that these microorganisms, bacteria especially, they actually, with the host, they actually use minerals, and like iron and zinc and magnesium for sure, as kind of like an arms race, as like nutritional warfare back and forth. And they know how to shut it off and they know how to turn it on. And in fact, with something like E. coli and the lipopolysaccharide, the LPS toxin, they think that might actually be a reservoir for magnesium for some of these cells, or bacteria. So when they're in a low magnesium environment, they can, sustain. So that to me was fascinating. And from that, I then got into, that shifted for me the whole perspective on minerals and humans and the host. And it started bringing in this whole other area of the microbiome, which, I know about before, but it's just like, oh yeah, they absorb stuff in your gut and they help you. And if you get pathogens, well, that's a problem. You want to get rid of them, and so on and so forth. But there's so much more going on that we could not exist without our gut microbiome and our skin microbiome, and our every single organ system has a microbiome with specific bacteria that help us to be able to survive. So that brought me to this new emerging concept, and I'm sure it's a paradigm shift now. It's called the holobiont, which means whole life organism. That and less we are really looking at the bacteria that we have on board or not, and anything that we do with our medicine, anything that has to do with anything in our health and what we eat, then we're totally missing the point, and we're not being able to move forward and to be healthy. So anyway, I think that's one of my biggest take home messages is the gut and everything that we're doing. We're not just feeding ourselves, we're feeding them too.
Absolutely.
And then they help feed us back.
So how do you tie the pieces of the puzzle together with the oxalates in the gut?
Okay. So what happens is with the antibiotics wipe out. I mean, it's like 10,000 fold in like a 2-week period. You wipe out, and hopefully some of them will come back. But the biggest problem is that Oxalobacter is like a very small amount in the gut. And it's a real kind of canary in the coal mine for antibiotic damage. So a lot of the primitive cultures still have Oxalobacter in their guts, but a lot of, I think it's maybe only a third of adults in the US have any. And so, it's not just Oxalobacter that clears. That's the one that does thrive on oxalate, Oxalobacter formiges, O. formiges. But there's a whole entire network now they're uncovering, since they've had such a major advance in the technology and being able to sequence these. They can find it because, see, most of those bacteria are anaerobic, so you can't really culture them. So you needed to be able to find them in another way. And now within the last 15 years, I think, or you can correct me if I'm wrong, but I think with the next generation sequencing that they've been able to do, we have like so much more information. Now we're just not looking at what's in there. We're looking at what are they doing? Because another interesting fact was that a third, or a little over a third, of all of the metabolites that are in our blood right now are microbiome produced. So, if we don't have them, we have certain kind of vitamins, like the majority of B vitamins are manufactured in the gut by bacteria. Now back to oxalate, when you wipe out some of those bacteria, some of those bacteria make 86% of the DRI, dietary recommended intake of B6 or pyridoxine, which, okay, you don't have that. That's another thing that is tied in to oxalate intolerance. So, getting some of those B vitamins back in, and, with the right healthy bacteria, not necessarily taking in a supplement, but, to really, have everybody in the orchestra there to be able to, help you digest and absorb your food. And then also they cross feed one another. But anyway, so more on oxalate. Oh, what other questions? Dr. McCullough, here's a question for you. What was the one thing in the paper, in the article that I wrote, that really was maybe your biggest aha?
Well, it wasn't really an epiphany, because I've been studying this for quite a while, and I have some theories on it that I'm going in the process of doing experiments to prove. But you're the first person I've seen that understood this, at least at a bigger level. So I was really curious at how you got to your position and wanted to dialogue about it, because and in your process of you're really ahead of the curve. Your appreciation of this is really quite extraordinary from my perspective. So, and I'm wondering, in your efforts to understand this, if you come to the conclusion I have, that you can simply divide the bacteria. First of all, 99% of the bugs in your gut are in your colon. 75% of the ones in your body are in your colon, but 99% of the ones in your gut are in your colon. Very few in small intestine, very few in the esophagus or stomach or the rectum. They're mostly all in the colon. So how would you divide them into two categories? What do you think is the most powerful categorization of those bacteria?
Dividing in terms of type or
characteristics.
Characteristics.
Yeah, like two major types. If you were to divide them, what would you think the two categories would be?
Oh, I'm not quite sure if I follow you. You know what? I can say this. Quality. I think one of
qualities, maybe characteristics. Metabolic characteristics that they have.
I think, the ability to break down, the ability to communicate with one another, the ability to, and for me, big thing is producing the short chain fatty acids, which take care of the host and also take care of one another. And I think,
so that's one characteristic, but it's an artifact or a result of some broader, more fundamental characteristic. And producing the short chain fatty acids like propionate, butyrate, and acetate are essential, but they're only by one class of bacteria, general. Then the class is, these are bugs that abhor, cannot tolerate oxygen. They're called obligate anaerobes.
Right, anaerobic.
No, obligate.
Obligate.
That means any molecule of oxygen will destroy them.
Right.
Then there's the other band, which is the facultative anaerobes, which are oxygen tolerant. The obligate ones are oxygen intolerant. They die with oxygen. And the oxygen tolerant ones do not produce the short chain fatty acids. Not only do they not produce them, but they produce, because they use oxygen as a fuel source, they can make a far more virulent endotoxin, because they both of these bugs produce endotoxin. But the ones from the oxygen tolerant ones is really nasty. And I think that's the crux. And I certainly didn't understand this, but one of the primary functions of, there's two types of cells in the colon, the colonocytes and the goblet cells, essentially. And the colonocytes are about 80%. And they not only do they serve the barrier, the actual lining of the gut, but they perform beta oxidation, and they're almost exclusively metabolize these short chain fatty acids. And in the process, they suck the oxygen out of the colon. That's how the oxygen is depleted. So if you can't supply these colonocytes, and they produce every 3 to 5 days, if you can't suck that oxygen out of the colon, you are in deep weeds. And because and they have to grow, so they need two things. They need food, which is the short chain fatty acids, which are produced from the fibers that you eat, typically healthy foods like vegetables and fibers that we get in food, apples, fruits, polyphenols. They all nourish these guys. But they also nourish the bad guys. And if you have a preponderance of the bad guys, it makes it really, really hard to get rid of the healthy fibers. Not to get rid of them, but to eat healthy, because if you eat healthy food, it makes you worse, because you get this radical increase in endotoxin, which can kill you. It actually is, in my view, and I think if you study it, you'd probably agree, the number one cause of death that exceeds heart disease and cancer. It's endotoxemia from these bugs. So, and the problem is you get in this black hole of death, because you need energy to make that to have the colonocytes reproduce. You have to have cellular energy, and if you don't have it, it gets this cascading downhill spiral that just gets worse and worse and worse. And no probiotic in the world, not even the obligate anaerobe probiotics, which exist at this point, but they're all fatally flawed. No one has yet figured out how to take that raw material and put it in a capsule and get into your gut. It dies in the meantime. No one's done it yet. And there's a lot of fraud going on in this area. And I'm going to expose it shortly. But they use something called AFUs. I don't know if you looked at those versus CFUs. Yeah.
No, I haven't.
That's a fraud that they're doing to get away with this.
Yeah. And I was looking at probiotics, are like in 2020, they were $35 billion a year, and they're expected to go up to like $73 billion.
I think they're at 70 billion on a global market right now. Probably they're going to 100. And because of this interest, if you look at the literature on this, I'm sure you have, it's just exploding. I mean, absolutely exploding. I'm writing and I'm putting the references together in my book, and I literally could find like 10 massive papers just from this year alone in like one little specific area. They're just putting them out like crazy. It's this is a very hot area of research, very hot area, because people know. I mean, the researchers know this is going to be good. And you're right. We only had the technology to figure this out about 20 years ago. Be the DNA sequencing, because you can't, it's inordinately difficult. There's only a few labs around that can culture these things, because to culture, you need an anaerobic environment, and that is, a few molecules of oxygen, and these buggers die. So that's why, you can do it. And the problem with these things, though, is that, or the whole assays, is the microbiome, the microbiome evaluation, the kits to determine that are so expensive, like $500, like at a base.
Right. That's a whole other market. That's a whole other market.
100%. And you know what? I'm sure you've looked at them. They're not focusing on the good guys. They're not. I mean, some of them, they have a few. Some of them have Oxalobacter. Some of them, Akkermansia, of course, is the leader. But they only measure a few of them. There's like 24 of these obligate anaerobes, or the oxygen intolerant bacteria. And there's no company I know that measures all of them. So that's another, because they're focused on the pathogenic bacteria, and you can't.
Right.
The goal isn't to kill these guys. Certainly, we know what happens with antibiotics, but you can't even use natural antibiotics like herbs and artemisia and all these other things. Yeah, they might be helpful, but it's not the strategy. The strategy, and you hit the nail on the head. You identified. You said processed food did it. You're absolutely right, 100%.
Absolutely.
That's what catalyzed the whole thing, and we know it happened around the American Civil War. Before the 20th century, clearly before, and everything started going downhill because what that did, those processed foods, it's not the sugar. I'm sure you understand it's not the sugar.
Oh,
I don't think.
I've got more research on that. We can talk about that on
talk about it. But I contend that it's not the sugar. Sugar doesn't help, but what's a dangerous one is the omega-6 fat.
Well, that's huge. That is huge.
It's beyond huge. It's almost indescribably dangerous, because that's what catalyzed the mitochondrial dysfunction that caused the colonocytes to die, that caused the gradual intrusion and increase in oxygen concentration in the colon that caused this cascade of death in your microbiome that almost no one can get out of unless you have a very specific intervention to do it, which is not easy.
Right.
Virtually no one escapes this. It's just, you just continue accelerating death until you die, typically prematurely. You lose about 1/3 of your lifespan because of this. 1/3. One out of 3 years is lost to this.
Another thing I was thinking about as I was kind of preparing and kind of just trying to pull everything together, not knowing where you would want to take this interview. But one of the papers that I wrote during my doctoral studies was on de novo lipogenesis,
DNL,
and the red blood cell membrane. And it was really interesting that the saturated fat that ends up in the red blood cell membrane is a product of de novo lipogenesis. It is not what comes in through our diet. And that, again, what happens with the N6s in that membrane, and, how that just, and now segueing back into oxalate, I was surprised too when I came up, and I have to have concept maps, because I believe in this, having, like I mentioned, having been a film editor, an LA film editor, that, we think in pictures and we learn through stories. So for me, it really helps to, put things together. And that's why I, have a lot of pictures that I put together for my article, just to kind of lay it out. You can see how everything kind of joins together, because we can get so dialed into something that we forget how it interrelates back. And I think that's one of the other things that's so fascinating about the gut. It's just not our narcissistic humanism, that it is like, okay, there's not just us here that we have to consider.
Yeah, there's 10 times more of them than there are of us, our cells.
Actually, you know what? What's interesting in my research, what I found is that we're almost 1-to-1. They've recalibrated those numbers.
The old data was
That's old data. And you know what? If anybody says that, you can point that out. It's old data that, what is 150-to-1 of what we have are the genetic potentials that they give us.
Wait, that the bugs give us?
Yeah. They give us 150 times the genetic, because they can do horizontal
the DNA exceeds ours by 150 times. Okay, I was
right, because they're single cell organisms. Like, we take how long to change our DNA, but they can change it rapidly, which is amazing. That is one of the things that enables us, to live anywhere on the planet, because they'll switch around for us to adapt, because they want to live, so they're going to help us live. But getting back to the concept map, when I started looking in and seeing how the the N6s, the polyunsaturated, the omega-6s, how they actually feed into the advanced glycation end product, which then feeds into the got glyoxylate, which then ends up as oxalate. And I'm like, oh my goodness, all this processed food, the sugar, again, the sugar going in. And the other thing too
but the N6s are 23 to 28. I mix them up because they both look like, if you add the 3, it looks like an 8, but it's either 23 or 28 times more likely to increase ages in sugar than sugar is. 23 times, just 2,300%. It's the omega-6s.
Wow. Yep.
Yeah.
Yep. Which are artificial, we're not supposed
they're processed. They're processed.
That process stuff that we've had since the industrial, really since the, who was it? The Procter and Gamble started hydrogenating the Crisco.
That's right.
Way back when.
The beginning of the death spiral.
Right. So also with the gut, what it was really interesting about oxalate that I found was when you peeled back, high oxalate in the urine, and what is causing kind of the damage is a disrupted gut. It's not dietary. That's only like 20%. Yes, it's diet. It's processed food that we've been eating. Or if if you're a vegetarian or something like that, vegetarians, I think they've done a study vegans, let me correct. Vegans eat more processed foods than vegetarians. And, I think definitely the vegans are, highest in the processed food. And that's where you're going to get most of the, advanced glycation end products, the AGEs and that. And also, highly processed food is really what is destroying the gut. And then that lays everything open for oxalate. And then you want to correct. And so you start eating healthy, and then you get even sicker. And then instead of blaming the bad food, you blame the healthy food.
Yeah. Because oxalate, it's 2 carbon dioxide molecules joined together, dicarboxylic acid. So when it's digested and liberated, it actually nourishes your gut. It's a health food. Oxalate is healthy if you can digest it. The problem is very few people can, because the oxygen intolerant bacteria, Oxalobacter, is one of those. It's probably, I think it's the second most important bug that we have of those that type. The first being Akkermansia, of course. And there's a dozen others at least, if not 24. Maybe some of the smaller ones they play a big picture, but Oxalobacter and Akkermansia certainly do. So when you have these omega-6s, it destroys the mitochondrial function. You can't deplete the oxygen. So Oxalobacter dies, and they can't digest it. Now, you had mentioned in your papers that you wrote that it was also, I think, Lactobacillus and Bifido that can also metabolize these oxalates, which I wasn't aware of until I read it in your paper. Right.
Now, and they're finding a whole bunch. It was hard for me. I really wanted to paint a big, broad picture that it's not so, oxalates to answer, what's your question? You know what I mean? Kind of a thing. I thought, we need to come around and look at this. And I think, Dr. Mercola, one of the things that I do is that I keep trying to break down assumptions. So if I find something, I go, okay, what is it that I have to assume in order to take this as a fact? When you keep paring down assumptions, you start finding a whole bunch of different things. Like I said, my assumption was, the Inuits, oh no, they just eat whale blubber. No, I went, okay, let me make sure. Let me see what their diet is, and we have to do that. If somebody says, so-and-so, I had crystals someplace here or something. Well, you know what? Part of the other thing that I wrote about in my paper is this whole process of forming kidney stones, which is biomineralization. And it's an ongoing process. It's been, through millennia. And the fact that, it really kind of surprised me when I was looking at how, again, a bacteria has a water shell, and when it gets saturated with magnesium or something else, it precipitates out and starts to make crystals. Well, that's exactly what happens with oxalate and calcium around the kidney stone. It's also how we got fossils.
Mm-hmm.
And that one of the things that I was really surprised to find was that when they went to the core of one of the I was getting backwards, stalagmites, they found 4 of the same bacteria species that are in our guts, naturally occurring in our guts. And I thought, wow. And you know what? They're all over trying to help us, but we're not helping them. We haven't been helping them anyway. But
so I have want to challenge one of your suppositions, because you seem to embrace that. So if we both agree that omega-6 is a problem, and also I'm sure agree that mitochondrial dysfunction, or the lack to create sufficient cellular energy, is another massive problem, and I believe the core of all disease. So if that's going on, and as a result of that, you've lost the ability to maintain a high enough concentration of the good bacteria, the beneficial bacteria that actually digest the fibers, the healthy fibers in our food, our vegetables and grains. Mm-hmm. And so we lose that ability over time. Most of us have lost a significant portion of that. So that when we do eat that, we actually get worse, because we're feeding not the good bacteria anymore, because they're not there. They left because the oxygen is there and they can't survive. So it's been taken over by a process called competitive inhibition. It's built up in these pathogenic bacteria that make this toxic endotoxin. So when you eat the healthy foods, the foods that are historically all our ancient ancestors had, and they didn't have the deal with processed foods, so they had a healthy gut. They had oxalobacter. That wasn't an issue. And they could eat this food, and they had the obligate anaerobes, and they converted the short-chain fatty acids. They fed their colonocytes. The GABA cells were happy too, and they kept the oxygen out. It was no problem. But now that's not the case. So if you're making that assumption, I don't think you would disagree that's a safe assumption. Where we're at today, state of the art 2024, State of the Union would be more accurate. So if that's the case, and it's true that eating healthy carbohydrates could be a huge problem, then maybe our supposition that sugar is not good for you maybe need to reconsider. And I'll tell you why. In my view, the healthiest fuel for the mitochondria is glucose. It's not fat at all. Actually, fat increases reductive stress and just slows down the electron transport chain. In most cells, not all, there are some cells like the colonocytes that are really burn fatty acids. They thrive on beta oxidation. So are sort of our heart cells, sort of our muscle cells. But most cells require glucose. So if you had glucose and took, we all need about 200 and 250 grams of carbs a day. That's a lot of carbs. Anyone eating keto or carnivore is not. So anyone on carnivore is carb deficient. There's a lot of consequences from that. So but they get better. Most people get better on carb or keto. I mean, carnivore or keto, because they stop feeding those pathogenic
bacteria. They're healing their gut. Yeah, they're healing their gut.
They're healing their gut. No, well,
it's protein, because protein's important.
Protein is the same no matter what you're doing. Protein doesn't change. I don't care what diet you're taking. You should always have about the same 0.8 grams per pound of body weight, and 30% being connective tissue or collagen. That would be their going. Because actually, I just found out today, I read an article from earlier this year in Cell. You would be interested in this. There's an amino acid called proline, which is one of the 3 big amino acids in collagen. Proline, it turns out, is a very powerful anti-aging amino acid. It actually decreases cellular senescence, and it increases mitophagy massively by activating AMPK. So not that I'm suggesting you should take a proline supplement, but maybe you might want to consider taking more connective tissue in your diet.
It's my favorite. I love all that. But
anyway, let me continue this. So in my view, the safest carbohydrate to take, not long-term, I'm not suggesting someone do this for years, but short-term, to get out of this ditch, is to consider taking glucose, or it's more commonly called dextrose, which you can buy. It's pretty inexpensive. It comes as a sugar, $5 a pound. And this sugar it's not sucrose, table sugar, which is a disaccharide. This is a monosaccharide. It's just one molecule of glucose, also called dextrose. And here's the cool thing about it. It never reaches your colon. all of that
Huh.
glucose is absorbed in the small intestine. It never goes to
Okay.
colon. So because of that, it avoids the complication of providing fuel to the facultative anaerobes, the pathogenic bacteria that can make endotoxins. So rather than not having any carbs, which is highly, highly problematic, and although there is benefit superficially, long term, it's this bad move. And almost everyone who does it will get worse because your cortisol level goes up, glucagon, adrenaline, bad news.
Mm-hmm.
So because your body needs, if you don't give it 200 to 250 grams of carbs a day, it's going to make it. And that process of making it's going to sacrifice your muscles and it'll increase your stress hormones. Not a good strategy. Thank God we have it because some of us need it for a variety of reasons. If we don't have that, we're probably dead. But if you activate it continuously, you are in for not a pleasant future for sure. So that's my supposition for it to challenge you, is thinking that maybe for a few weeks, just pure glucose, especially for those who are seriously damaged, who don't have the capacity to eat virtually any carbohydrate. And actually, I'll tell you one person who we both know who is in that boat is Sally Norton. She is so compromised for a variety of things that happen that she just reacts to all these types of carbohydrates. She's a real extreme example of that. And there are many other people like that. And so you can go on this high dextrose diet for a while until your gut starts to heal. So you have more cellular energy. You get the carbs back in and your mitochondrial function starts to be restored. And you do things to heal the gut that are very specific, that essentially deplete the oxygen out there and aid the colonocytes from doing their job and getting them back up and running because they're like, if you saw pictures, I would be like, you like pictures, right? It's like these colonocytes, they've got bandages on, they've got crutches. They're like, they've been through the war.
And they're rubbed down.
And that, they're like the tiles on the space shuttle, right? All the tiles have to be there for it to work and get into reentry. And if you got a few knocked off, they're just about as big. And if the colonocytes are gone, you got leaky gut. You have a physical hole in your gut where these proteins can simply leak through. It's not a hard concept to imagine. It's a hole, physical hole, because you can't make these colonocytes. So you get autoimmune diseases through the roof. It's just a mess. So anyway, that's what I wanted to talk to you about.
Well, and I do 100% agree with you about sugar, about dextrose. Well, that's what they put in IV solutions.
100%. That D5W dextrose, D10W, right?
Right.
I don't like the plastic. When I was, they used to put it in bottles, but now it's
but the glass. Okay, that's a whole other vortex. Is the aluminum that can get sucked out of that special kind of glass. But anyway, and I've done
were you a hospital nurse?
Research.
Were you a hospital nurse?
Yes.
Okay.
Yeah, NICU. Mm-hmm.
Oh, well, you did a lot. So did they use glass bottles back then?
Yep, they did, and that's why they're finding.
I've not heard of this aluminum coming out of the glass. Is it a special type of glass they use for IV bottles?
Yes, it's like a special type of Pyrex.
Wow!
And they use aluminosilicate. I've got all of that.
Why do they use that? Why are they using that?
Well, I think it was. I have to go back and look, but I have a whole research thing on aluminum because Dr. Mercola, back to my water, after I finished doing my dissertation, and everybody was like, "You've got to publish your dissertation." I started doing some more research to update it, and I found basically my thing about magnesium is that once they started processing the water and softening it, they've stripped out it's magnesium more than calcium, and that you need magnesium. You have to have it in every single cell. You cannot make ATP without it. The majority of it is inside the mitochondria. So I'm right there with you on that.
ADP to ATP, that's in complex 5 ATP synthase, you will not. You have to have magnesium to make that step. It doesn't work without it. Yeah. So most people don't know that. It's essential.
No, and once we started processing water, that's when our cardiovascular disease, that's one factor, but it is linear all the way up.
Mhm.
as we started switching to municipal water, and we also started softening the water. Now reverse
Yeah,
osmosis, that's a
and fluoride.
whole other
Don't forget fluoride.
Okay, fluoride. But here's the other thing too. They started putting aluminum into the water
Yeah, that aluminum's
to
toxic.
flocculate.
Yeah.
And here's the thing, magnesium and aluminum.
Wait.
Magnesium.
Why did they put aluminum in the water? Tell me again. Was that
Um,
the fluoride? How did
no, it was to flocculate. It's
the
to pull
flocculate
out
what?
some of the, in the process, to pull out some of the particles to clear it.
Oh,
Because it used to be zeolite, clinoptilolite, or something like that. And then they got this aluminum powder. So they started putting aluminum powder in. And
is this most municipal water supplies?
yes.
I
And
have
guess
not
what?
heard that.
91. Oh, we can talk about that in another.
No,
I didn't mean to go off on a magnesium tangent.
no, these are all important topics. I mean, oxalates is important, but all these things you're talking about are really crucial.
But see, magnesium also helps to bind oxalate and get rid of it. It's really important, and it's
and calcium binds it too, for sure.
For sure.
They both do it, and potassium. So all those cations do that. So, but you have to have a surplus. You really do.
But that's why
you don't even need those if you have oxalobacter thriving in your gut. Because
but not everybody can have that, and not until they can come up.
Yeah, you're right.
Until they can come up with some kind of probiotic in that way.
I'm actually going to be introducing one pretty shortly.
Okay.
Yeah, and actually we're starting some no one's yet grown oxalobacter, but I've got a research team on it right now to define the protocol, because these bugs are very, very difficult to grow, and it requires millions of dollars of investment to identify the specific protocol that causes them to thrive, and then to harvest them, and then even beyond that, once they're harvested, you still have to have the technical challenge of putting in a capsule in a way that it doesn't kill them and gets them into the gut. So I'm hoping we'll have oxalobacter within a year or two, hopefully closer to a year.
Wow.
But that's one of our hard priorities, to get that out, because, but if you put that, it's just like a seed. These are seeds, right? That's exactly what they are. And if you, because I'm sure you've done some farming, because you're Weston Price and you've done gardening or farming. So if you put a seed in the Sahara Desert and there's no water, is that seed going to grow? No, it's the same thing with oxalobacter. You can have the best oxalobacter supplement in the world, the best probiotic, just perfect. Right. But if you put it in most everyone's gut, nothing's going to happen. Nothing will happen. Nothing. It won't work, because you have to take care of what the foundational cause of the issue is.
Absolutely.
But if you take care of the foundational thing and you don't have the oxalobacter, then you're still in a hard place, because you still need a seed to start them growing, because most of them are all dead.
Right.
Yeah. So you need them.
But still, with a network, getting back to, kind of our ancestors in that, you think fermenting food, that's basically like having, an intestine outside that's doing all of that breakdown for you. And then when you can have, because that's what, and one of the things I found in my paper is how some of these, traditional cultures, they took these high oxalate foods and they were able to break down, because that's what's happening with fermentation, just like what's happening in our guts, is a breakdown and get rid of some of the oxalate and decrease the amount of oxalate.
Yeah.
So, I think that's something that's really important to think about too.
There's no question, but it doesn't produce these anaerobes. The obligate anaerobes, it just doesn't. But one of the things it does, and actually has saved many, many people's lives, and I'm not sure of this current status legally with the FDA, I don't think it's approved, but many people are using it for someone who does have septic shock, is the FMT, the fecal microbiome transplant.
Right.
That right now is the only source of these obligate anaerobes, these oxygen intolerant bacteria. But, there's a lot of problems to do that. You have to get it from someone's healthy, and most everyone's unhealthy. So,
or hasn't been exposed, and you don't know.
Yeah. So there's a lot of issues, but still, that shows you that works. That saves so many people's lives, and that's exactly what I'm saying. If you put the real live bugs in there, you can reverse this, at least temporarily, but you still have to fix the cause, why it caused it.
You have to go. Absolutely. And that's one of the big problems that I have with just like, stop eating oxalates. They're terrible. No, I can't. Yes, you need to know what they are. You need to be aware. But if you get rid of them, then you lose the bacteria.
Yeah, that was your
and that's
solution. And thank you for reminding me, because you said that was really brilliant. And you pointed out studies where they did that, where people went on these low oxalate diets, and they decrease their symptoms, but essentially you stop eating the bacteria that are used to do that, and it actually makes you worse.
And then you're going to absorb more oxalate. And since your body is making it anyway, you know, not eating it in food and chocolate or anything else is not going to make it go away.
No, but I still think there's some value to not get obsessive with it. You know, I mean, not have
100%.
Like 2 grams of oxalates and think you're going to be off to the races. No, not a good idea.
No.
Keep it, keep it low. You know, don't go crazy, but still keep it low, especially until you get your gut fix. Which
exactly. But and there is a window, and I think I put through in some of those numbers. I think you shouldn't really go below 40. But I think a lot of people, you having throwing back a spinach smoothie. I mean, that's just, you've had like
a spinach
bypass.
Made with almond milk, right?
That is an oxalate bong. You know, I mean, that is bad. But people don't know, and they want to get healthy, and they think they're going to get healthy. And, I've heard plenty of stories where people, I just started eating spinach salad. And I'm like,
yeah, ideally, I wouldn't have a concentrated spinach, but we should be able to eat spinach. If you have a healthy gut, it's not a problem.
Yes,
it's not a problem. It's not the poison that people make it out to be. But for most people, it should be avoided because they just don't have the metabolic physiology in the gut to take care of it. And until they understand what I'm discussing in cellular health, no one has identified these principles before because it doesn't exist. Right now, we're between a rock and a hard place. As I said, people are dying. Almost everyone dies prematurely because they don't understand how to do this. It's not hard, but it's not obvious either. It's not obvious at all.
Well, we're doing what we were told. And now, Dr. Mercola, I was really excited to uncover this. Just in the last 10 years, now they are looking, how they've always looked at social determinants of health. Oh, your lifestyle, do you smoke, do you exercise, and all that. And they, they feed us garbage and then they blame us for getting sick. Okay. And then tell us we need to work out and eat, less sugar and whatever. Okay. Now what they're doing is starting to go after the commercial determinants of health. Now they are looking at marketing and really going after, because they did a whole bunch of reviews of articles and they pointed us as the consumers and not at these private organizations that are marketing to us and giving. So I'm really, really, really happy to see that shift, that it's, pointing back in that direction. Part of the way that I came across that was looking at addiction and the gut again, and looking at sugar again, and seeing how like cigarettes were not addictive until they started putting sugar into cigarettes. And it's the number one additive after tobacco in sugar is sugar and flavoring. And then in the 1960s with the, tobacco industry, when the Surgeon General started saying, okay, this is not good, RJR and Philip Morris went and took their flavorings and sugar and went into the food industry, started putting that same addictive stuff into the food industry, took their same process with marketing and everything else. And so that's where we go. So back to the people who think, they've listened to that and nobody, had enough sense or critical thinking to say, wait a minute, this doesn't make sense to me, or I'm not getting healthy or anything. I think people are waking up, certainly now in the last 4 years, more than they ever have. But
it's hard to have critical thinking skills when you're not making enough cellular energy, because your brain consumes 20% of your energy. And if you're not making enough, it's sacrificed. So you're not thinking the way you could or should.
Right.
If you don't have enough energy, it is impossible to think clearly. It is physically impossible, biologically impossible.
Right.
It's like trying to run your car with a very low octane fuel.
Right.
It just doesn't work.
Well, it's like, are you familiar at all with Dr. Ian McGilchrist? The left brain and the right brain.
I've not heard of him.
He's one of the thought leaders. He's a medical doctor, psychiatrist, also a neuroscientist.
Mm-hmm.
I think he lives in Scotland. But his work, what he found was the left hemisphere, right hemisphere, not like, logical and creative, like we had all that woo stuff back in the 80s, but really looking at stroke patients.
Mm-hmm.
And the left side of the brain is wired. His book is The Master and His Emissary. And the master is actually the right brain, which can see things in a holistic and relationships.
Mm-hmm.
And the left brain is I, me, my, focus, grab and get. And he gives the analogy of like a bird that is very focused on getting a worm or something. And that would be the left brain focused, but the right brain sees the world around him or her so that they don't get eaten.
Mm-hmm.
Okay. And I think to your point is like, when all the systems are not working, you're really left brain. Mm-hmm. You're only I, me, my, and you can't think in bigger, broader relationships and wider ranges.
Yeah.
Anyway, I think that's really kind of interesting. I think a lot of these things just do all seem to tie together, which is, the way that I like to look at things and, coming at it from a bunch of different angles. And then that way you can go, okay, well, it's, on this side or on this side, you're looking at multiple different disciplines and sciences and pulling stuff together instead of just going, oxalate's the answer. What's your question?
Right. Yes, absolutely. So you have to be careful of that approach, but to understand it's relatively simple, the answer, but there's some complexities that's important to understand, the nuances that are really vital to appreciate. So
and I'm just looking.
So do you have any resources that people, other than the article that you wrote for Wise Traditions?
For
a website, or are you planning on writing a book, or?
Well, yeah, I would like, the book that I would like to write is, going back to the neonatal work that I did, which really got me started, is I'm looking at I have a big whiteboard that I have a whole bunch of things I put down so I could remember. It's the first 1,000 days, and it is from conception to about age 3 when that whole microbiome is developed, and what we're doing. And I did write a paper during my doctorate on breast milk and the microbes and the mucosa, and the 3 things: milk, microbes, and mucosa, and basically how we get our gut colonized at birth. And at that time, I think that I don't know how many years ago. I need to update it because it's been a while. But at that point, we thought that the baby was born sterile. We now know that babies come out with, I think, 100 different species in the colon ready to go. And it comes, I think, from the mother's oral microbiome is what they've matched to the baby's colon. And really, truly getting into the antibiotics and all that, how that disrupts, and then other little kind of treatments that are given early and routinely, and how that disrupts this developing gut, and I think for people to understand really how it is created and what happens, because very high incidence of kidney stones when kids have had antibiotics later on. Well, they've disrupted the gut microbiome development. So
absolutely. That and the seed oils. I don't know which one's more dangerous. They're both pretty seriously pathogenic. There's antibiotics and the seed oils. Probably the seed oils worse, I would think.
Right.
I'm not a fan of taking unnecessary antibiotics. That's a prescription for disaster.
No, absolutely. And what, you brought up a really good point too, that even magnesium in the gut, taking a magnesium supplement, which I do not recommend, in terms of a pill form, but they found that can cause dysbiosis, because anything
in excess is a problem for sure, because it can cause stools, because it's a real common side effect for magnesium.
Yeah, well, it depends on the salt that it's put with. So mag oxide, mag sulfate, those are the salts that it goes with. That is really going to clear. And not a lot of it is absorbed. But, in the liquid form, again, going back to your sugar and sucrose, they found that that is the liquid sugar in sucrose and soft drinks and sugar sweetened beverages that is the most damaging to the gut, especially if it continues on from the small intestine all the way down into the colon. And then, it's just.
Yeah, that's why when I said sugar, most of that's high fructose corn syrup. And sometimes the fructose isn't that much more. It's maybe 55% fructose. So they have versions that are much higher. But fructose can be problematic for sure. But pure dextrose, glucose, has no fructose in it, zero. So,
right.
That's why I think it's a really safe carbohydrate. And, I've had people go on 16, 18, even 20 tablespoons of dextrose in a day and a half a gallon of water so they can get their carbs. They start to sleep better. They have more energy. They're thinking clearer. And then they gradually transition off. But it's very safe and it doesn't activate endotoxin at all. Just like a low carb diet would. Essentially, it's low carb as the colon sees it because it never reaches the colon. It goes into, it's almost like an IV. It's absorbed in the proximal intestine, very, very high proximal intestine. So there's no danger about activating endotoxin, which is the primary concern. Pete is a biologist that I have great respect and admire and really helped catalyze my understanding of this whole process. He didn't really appreciate the nuances of the carbohydrates, though. It's something I've done a lot of work on to understand. But it's once you understand that, then you can navigate through this process of recovering your health and giving your body the carbs it needs, which is really key. You need carbohydrates. It's just absolutely essential you get it.
It's interesting though. How do you figure this? That, we're born, in the womb, it's ketogenic. There are no carbs that are coming to us really.
No, that's not true. No, you're getting, you share the plasma with your mother. So she's going to have a normal blood sugar. She's got 70 milligrams per deciliter, 70 at the lowest. It's very rarely goes. And if she's has some insulin resistance, she could be significantly higher. So there's a continuous supply, unless she's hypoglycemic for some reason, but no, they get it. And her mother's doing it. And then, so they're obviously they're getting that through the mother. That's where it comes from.
Well, here's another thing to your that's I thought was, kind of fascinating, that human host only has 17 enzymes for carbohydrate, and the gut bacteria has over 200.
Yeah, it's because there's different type of carbs. The simple carbs, the monosaccharides, don't require virtually any type of enzyme to digest. The complex carbs, the starches, there's dozens and dozens, hundreds of different enzymes that break it down.
Right.
And most of those we don't have. We don't have it. That's why they're called fiber. It's undigestible. We don't digest those enzymes. The bacteria do. It's food for them. But if you've got the wrong bacteria there and they digest it, you're in for a nightmare. You are absolutely in for a nightmare.
Right. Another interesting thing I'd like to hear your thoughts on is looking at the fiber and looking at protein, that fiber is more distal, is fermented more distally in the colon, and as the pH increases is when they get to protein. And depending on the amount of carbohydrate in the diet is whether the bacteria will be,
you just can't say carbs. You have to be discriminating in which type of carb.
The fiber.
The fiber. So the indigestible carbs.
Yes, indigestible carbs. Yes.
Yeah, that's different.
So what they are going to digest in the colon. But we can also, here's what was, I thought, kind of fascinating, is that the majority of the studies have only looked at E. coli and I think it was Salmonella, and how they digested fiber, and they don't really work on amino acids. So that's why so much of the research has been, geared more towards that. But then when they started doing more research on uh, the fermentation of fiber, it's way later in the colon, almost near the end. And it actually, they do this, what the studies say, it actually produces the same phenols that fiber fermentation does. So again, the beauty of the adaptability of our,
you don't want phenols, you want fatty acids. That's the key thing. And as I said, the obligate anaerobes, the oxygen intolerant bacteria, they're diminished and absent in many people, which is sad but true. And they cannot make those short chain fatty acids because the oxygen tolerant ones, the facultative anaerobes, they can not make, they don't make those fatty acids. So they'll make other molecules. The most dangerous one, of course, is endotoxin, but they make other molecules, but not many that nourish the colonic epithelium at all.
Right.
So it's all about getting that ratio back. And the only way we can do it is by depleting the oxygen, healing the holes, and putting the seeds in that at this point in time, as we're recording this, do not exist commercially. Outside of a fecal microbiome transplant. That's the only hope.
Right.
It's the only way you can get it right now, today. That will change later this year. I assure you that will change. There's going to be some brands out there that have the real deal. That have CFUs, not AFUs in their
yes. Okay. Yeah. So how Dr. Mercola, would somebody know how to make the difference? Would you be doing some kind of a launch on that so people be able to tell?
It's the simplest way is to subscribe to my newsletter and pick up my
right. Oh,
yeah, because I know what it is. I can, I'm going to announce it. Yes, I've got a whole program and protocol I put together for taking me about a year to do, and I'm writing a book with hopefully about 2,000 references documenting to the current medical literature, scientific, actually, not medical.
Right, scientific literature. Yes.
Yeah, so this is not some whimsical fantasy. This is rooted in reality. And
there's such a need.
We're doing quite a bit of research on this too. It's been to documenting the microbiome changes with an assay that's only $50 that people can test instead of $500. I'm going to probably be launching that test hopefully in a month, maybe 2 months. About 2 months. I think we'll be launching it. And then also a way to test the mitochondrial function, which is the crux of all disease. So we're seeking to offer these as resources and tools that people can have these objective, independent markers that help them navigate their own course in health and try an intervention, not only observe how it makes it feels, but objectively see the results on their biology. So, it's going to be fun.
Yeah, no, I mean, it's so necessary because, and I think people really need to realize how important their gut health is. Yeah. Where the term holobiont came from was coral bleaching. If you are familiar with the coral, what happens is, if the algae dies on the coral dies.
Yeah.
If people don't know what coral bleaching is, and that's the same exact thing it is with our microbiome, wherever it is. If we don't have it, we can't thrive. So
I agree.
We have to nurture it. We have to remodel it. Maybe some people just never had good bacteria to begin with, so it's not like it's putting it back. It's putting it in for the first time.
We're all pretty much bored with it. Most people don't have, virtually no one has optimal microbiome at this point. There's maybe a few percent in the world that do. It's well under 5% for sure. I'm hoping with the protocol that I'm introducing that we can get that up to 20, 30, 40, eventually 50%. Because it's not that hard once you understand the principles. It's really pretty simple.
Right.
So that's the good news. So anyway, I've got to get back to integrating some more references into this book so I can get it out. But I so appreciate your work and so astonished at your insights and intuition and figuring these things out. You're well ahead of the curve. You've really done a masterful work at thinking this through and identifying out what I think it's a really a prescient approach to understand the foundational causes. And you couldn't be more spot on in my view to understand that it is the microbiome, that you've got to get that better. And if you don't restore that to its natural state, you have essentially lost any, and I do mean any, in bold 20-point font any hope of ever recovering your full health. It's just virtually impossible unless you restore the microbiome to its full and blazing brilliance of functionality that it has, and helping us restore the health because of all the things it makes. And just as a last aside is, the common one in 8 people have tried the GLP-1 mimetics like Wegovy and Ozempic. And 1 in 8 in this country, that's astonishing. And it's because they don't have the akkermansia. That is the way you're supposed to get this, is through GLP-1. That makes GLP-1. That's one of the many things that it makes, but it certainly makes that. And it's so effective that the companies that are providing this have gotten FDA approval to put a claim that says it treats obesity and diabetes because it works. But you don't need a $1,000 a month shot. You just need to restore your microbiome. Not kill yourself prematurely financially, but then even biologically by taking these expensive and absolutely 100% unnecessary and radically dangerous drugs. I don't think those should be taken off the market immediately. They're very dangerous. No one should be using these. No one.
Right.
Yeah. Don't even think about trying that thing, because there's other ways to do it. Other ways that are the right way, that you're going to restore it naturally, not through some drug that people have created to make money and kill you prematurely, for sure.
Right. And we didn't even get into the whole litany of what drugs do to your gut microbiome.
Oh, yes. Yeah. Of course, drugs. I remember in 1995, I wrote a letter to all my patients at the time and said, listen, unless you want to get off all your drugs, you're going to have to find a new doctor. That's a bold letter to write. You know why? Because 80% of my patients took me up on it. They left. 80%.
Wow.
Yeah. But then I was stuck. I was fortunate enough to have 20% of my patients, which was 100%. They were all compliant. They did what I said and they got better.
Right.
They got better. So yeah, it was a fun move, but everyone gets a choice. All right, Ruth, it's been a delight and a pleasure. I so appreciate my time with you, and thank you for sharing it with us, helping us understand these complexities.
All righty. Thank you so much, Dr. Mercola.
All right, you're most welcome. Bye now. Thanks so much for watching. Remember, hit the like and subscribe button so you can get more videos that can help you and your family take control of your health.